Cool, we're live. Hey everyone, good morning, good afternoon, good evening, wherever you are in the world. Welcome to our first ever liblab live. I'm Jim Bennett, Principal Developer Advocate at liblab, and I'm really excited today. I'm joined by Dallas, one of our engineers. So Dallas, do you want to introduce yourself? Say hello.
Oh, hello, I'm Dallas. I'm a software engineer in liblab, and I'm based in Brazil. Yeah, I think
Cool.
that's enough.
So I'm up in just outside of Seattle in Washington State, so top end of the US, and you're Brazil. Now Brazil's a rather large country, so whereabouts in Brazil are you?
Yeah, I'm in the Northeast, which is like 3 hours flight from São Paulo, and it's yeah, we are a larger country, and sometimes people get uh, surprised by how long it can take for us to go from one side to the other of the country. Like I think you need like a 6 hour flight to go from one point to another of the country. If that flight doesn't exist, of course, but if that exists.
6 hours, yeah, because you do forget how big some countries are. It's like Australia. You know, it's like if you want to go from one side to Australia to the other, it's like a 5 hour flight or something. So Brazil's kind of the same. It's
Yes,
quite a long way.
yes.
Cool.
We are the reverse of the US because Brazil is like this and the US is like this, but they're both big in in their ways.
Yeah, because I guess if you're going from the top of Brazil to the bottom, that's the long flight. It's one
Yeah.
side to the other. It's the small. We have Milan on the line. Hey Milan, how you doing? Great to have you join us, hosting a Brazilian flag there. Nice, nice. Let us know where in the world you are. So, you know, it was always great to have people from around the world. I've live streamed so many times in the past, and it's always fun when you have people from literally everywhere. I think one of the most fun ones I find is I do a stream at kind of this kind of time, and you'll get like students from India online, and it's like, midnight for them, 1 o'clock, 2 o'clock in the morning, whatever. And they're like, yeah, our university's not so great. We hang out on streams in the evenings, we can learn stuff. So it's always good when you get people from around the world. So Milan's from Serbia. So it's great to have you with us from however many hours away you are. That's probably what, 9 hours time difference from me. So great to have you there. Oh, and Sagiv's on the line as well. So everyone be nice to Sagiv. He's the boss. He's the founder of liblab. So Sagiv, great to have you here with us. Anyone who's watching, please jump in the chat, get involved, have that conversation with us. We're here to show off some cool stuff, but also we're here to answer your questions. So if there's anything you want to know about liblab, anything you want to discover, learn, ask us, whether it's what it's like to work at liblab or how our SDK generation works, or want us to dive deeper in anything, we're here to help you. We're here to take your questions. We're here to talk about Python SDK generation mainly, but obviously we're here to support you and answer your questions. But before we do, Dallas, I do want to get to know you a little bit better. We've worked together, but I haven't had much of a chance to get to know you. I'm spotting 2 guitars in the background. Now, we did touch this a bit earlier. I used to play guitar, and I kind of keep my my trusty axe here in the hope that I remember to pick it up and play it, but I don't. I probably can't remember how to play anything. But you are a musician, I'm guessing, by the fact you have those 2 guitars there.
Well, yes, my first job was teaching music actually when I finished high school for some period, and yeah, I always enjoyed playing, but I mean, life comes, and then today I don't play as much as I played before, but yeah, I like to play, and I usually play music that have the guitar on center, like blues and I used to play rock, but today I'm more into blues and of course some classic stuff like Jimi Hendrix and that stuff. But when you used to play, did you used to play?
So for me, it was mainly kind of rock music. That was the main thing, and indie music. So I guess what the world would refer to as Britpop. Bands like Radiohead, Blur, things like that. I used to play that kind of stuff. Used to even have a whole recording studio set up. In my garage, I had like a whole recording set up. So I used to jam with different people, record music. But that was, 20 years ago. So you know, I have my guitar out in the hope that I will get around to playing it, but I haven't. My kid, actually, I've got an 11-year-old, and they play drums, guitar, and keyboard. So I need to kind of, you know, I need to get playing with them, I think, just to try and get back. But we have Joshua has joined us. Joshua Pendragon, great to have you with us. Joshua, where in the world are you? And I guess in keeping with what we've just been chatting about, do you play a musical instrument? If you do, what do you play? Let us know. So yeah, cool. So we're here to talk about Python. I think we're here to talk about Python. We can probably talk about music all day, but I guess we're here to talk Python. So Dallas, you actually worked on our new Python SDK generation. You are the hero behind this.
Well, yeah, I did some work, but the team is, well, always not only me.
So modest. You are the hero. You created an amazing new SDK generation. And so for folks who haven't seen this, Dallas actually wrote a really good blog post. I'm going to drop a link to this in the chat for everyone. In fact, you know what? I'll even share my screen and bring this up. So Dallas wrote one of the best blog posts that we've done recently. I have to give a shout out to Dallas. I was just blown away by the quality of what he produced, and I keep saying it. It's just absolutely great. But we've got this great blog post that Dallas wrote about our new SDK generation. So the big thing you mentioned here is usability, efficiency, and developer satisfaction. So do you want to just explain really what the aim was behind version 2 of this?
Okay, yeah. We had our V1 SDK that had some, it was a good SDK, but we missed some things that our clients were asking for, some features that we didn't have support for. And like to accomplish that, we decided to create the version 2 of the SDK. So this version is focused in the usability, like the blog post says, and the efficiency, and like in giving the user the way to use the SDK as he wants. So we managed to protect the user from the bad parts of Python, like the dynamic typing. That is a very controversial feature of Python. It gives you freedom, and that's the pro and the con of the language. Like, you have too much freedom. You can do whatever you want. We wanted to keep this ability, like the users can use the SDK as they want, but we wanted to also protect them from like spending too much resources where they, like, if they just commit a typo or something like that when they are sending information. So yeah, those were the main objectives behind it.
Yeah, because Python does it gives you enough rope to hang yourself, to use kind of an old-fashioned expression. Yeah, I mean, I'm a huge fan of very strong typing. You know, I love languages like C# and Rust. We've got this very strong type safety. And even, I must admit, when I'm using Python, I like Python, but I'm always putting type ins. And the thing that bites me most is just that lack of type safety. So just having that built into the SDKs we produce, I think, is really, really powerful feature. And I do want to just touch on another of the comments you made. You said about, we created a first version of SDKs. We gave these to our customers, and we got that feedback from them around, yeah, this is great, but here's some things we could do better. And I think that's kind of a testament to some of the work we're doing here at liblab. Is we want to make sure that not only are our customers happy, but the SDKs they create are great, so that our customers' end users are happy. And just the fact that we've been taking that feedback and using that to produce the next version, I think it's great. You know, just shows that we are listening to our customers. There is so much that we can do, but until it's in the hands of people, there's so much we can learn when people are actually using this in anger. So I think it's great that we're doing this iterative approach. We've created one, now let's do it better. Just jumping back into the chat briefly. So Joshua is joining us from Austin in Texas. So Austin is actually where our kind of head office is. It's where our CEO lives. And yes, as Joshua mentions, he asked us in Discord about some presentations that I was giving. You know what I'm going to do? Seeing as you've mentioned our Discord there, Joshua, I'm just going to drop a link to our Discord in the chat. Let me just print that. So if you're interested in liblab, you want to learn more, our Discord is a great place to start. Apologies if you're viewing the stream on LinkedIn. Anything I post won't get posted on LinkedIn. There's kind of limits to how LinkedIn integrates with the various streaming tools. So on Twitch and YouTube, you'll see that link. LinkedIn, I'm afraid you won't. But Joshua, you've already got it. I see you're joining us from LinkedIn. But yeah, if you want to jump on our Discord, ask us any questions, that's the place to go. And Joshua also says, I play mandolin, which is cool, because the mandolins are kind of like a guitar, a little guitar type thing, isn't it? Is it?
But to be honest, I don't know what's a mandolin.
Yes, it's kind of the round-bodied guitar, often associated with kind of bards. So when you have like Dungeons and Dragons game, you have bards there playing the mandolin.
Yeah, we have a different name for it in Brazil.
What's it called in Brazil?
It's banjo.
A banjo?
Yeah.
It's kind of different from my understanding of a banjo, because banjo, to my understanding, is kind of more the flat.
Oh, yeah, that one as well. I don't know why we call the two they two have the same name, but we have something different with guitars. It's all guitars for you, but for us, the acoustic one is violão, and the guitar, the electric, is guitarra, which would be the same. So yeah, we use the same name for these two instruments, but we have different names for the two kinds of guitars.
So a mandolin and a banjo is basically a banjo, but an electric guitar and acoustic guitar has a completely different name. That's cool. That's cool. So yeah, Joshua says that the string tuning is like a violin. Okay. And I wander around Renaissance festivals with it and play songs. Yeah, because that's kind of what the mandolin to me is what like a bard would use. So yeah, kind of imagine someone with the floppy hat and the medieval clothing, whatever, you walk around with the mandolin singing songs about slaying dragons or whatever. So that's cool. That's really cool. And I will actually have to add this comment from Joshua as well. That's the Rust crab. Yes, I do like Rust. It's what I do for fun. Dallas, have you ever used Rust?
No, and I just checked that I made a mistake. The name in Brazil is bandolim, not banjo, but it's with a B as well. So I did this mistake.
A mandolin. Yeah. Okay, cool. Yeah, that's really cool. Yeah, I've not come across anyone who plays the mandolin before. So Joshua, thank you for sharing that with us. Cool. Right. So yeah, back to SDK generation. I find this a lot with the streams I'm on. They go absolutely all over the place. I did the series in a while ago, the previous company I was working at, where we were trying to solve leak code problems, and it took us like 3 episodes to solve a basic leak code problem, because we were just wherever the conversation took us, lots of people jumping in with comments. It took us all over the place. So yeah, if you're watching, we want to geek out on stringed instruments as well as SDK generation. So please, jump in the chat with any comments. We're more than happy to geek out on absolutely anything right now. We will talk about SDKs, but we'll also whatever answers you want, we're happy to join. And yeah, Joshua, thank you for sharing your mandolin stories. So this blog post, I shared it earlier. I'll drop it back in the chat for anyone who's just joined us. This is kind of a guide to kind of the new features that are in the Python SDKs, isn't it? So this is kind of what we want to talk about today, really. So as we were saying, Dallas, it's about usability, efficiency, developer satisfaction, and just dealing with the type system, because Python's type system is questionable. So I think the first thing I want to talk about is input casting. It's kind of the first thing mentioned in your blog post. I love this quote here: simple is better than complex, complex is better than complicated. So do you want to just tell me about this input casting that we do?
Yes. So first of all of these phrases that I put in the start of the topics are from the Zen of Python. If you import these in Python, you can get them all.
Zen of Python. I'm going to just...
Yeah, it is that text. You can
Oh, nice. I'm going to drop that in the chat for everyone. Yeah. Cool.
So yeah, that's the Zen of Python, and it has some cool concepts, but it's very abstract. So I wanted to use it, some kind of poetry in the coder way of poetry. But yeah, so we wanted to give the users freedom to use Python as they are used to. So if that's by sending a dictionary or by sending a typed object, we wanted to allow that, as long as it matches the the spec for it. So if you say that you need to pass an email, then that should be an email, or your object contains those properties. It should contain if you pass the type object or the dictionary. So we created this decorator to cast, if possible, the things that you are sending to the original type that we are expecting. It's because since Python is dynamic type, the types we see in the signature are only type hints in the end, because you could pass whatever you wanted there. So we are checking if whatever you are passing can match the type that we are expecting, and converting it to a type that we can validate better and use across the SDK. So yeah, that's the main idea of it.
Cool. And this is actually in the generator SDK, isn't it? So if I'm generating an SDK, what I generate, what I then give to my end users, has this decorator in it.
Yes, in the
Okay.
methods.
I do have an example here. So now I gave Dallas complete control of my Visual Studio. If you've not used Visual Studio Live Share before, by the way, excellent tool. Dallas currently has complete control of my Visual Studio code. You know, no hands, and he's doing things in my terminal. I am running this in a container, so Dallas can't go wild and start deleting. No, no. Yes, top tip: only ever do live share in a container. No one can then delete your home directory. Oh, Joshua's got a good point here. Actually, says sounds similar to Zod for Node. Now, you probably know this better than I do, because I don't really know Node, JavaScript, TypeScript very well. But Zod, that's the thing where you can define like a schema for an object, and then if it doesn't, you can pass JSON around and it will just match it to that schema or create it from that schema. Is that right, Dallas?
Yeah, Zod is a big library, so it does a lot of stuff. One of them is validating. It can be used to validate the input. We did that in a level that we need for an SDK. So we didn't want it to put, because Python have some similar stuff to validate the input, but we wanted that our SDKs were like as clean as possible and had the small size as possible. So we build our own solution that contains only what's necessary for our specific usage.
So kind of like Zod, but just more lightweight, very, very specialized. And as Joshua puts it, runtime schema validation. Yeah. So Joshua's a fan of that. And also, Kaposki, I'm not sure I'm pronouncing that right, apologies, says Python may have dynamic types, but APIs do not. Having client-side type validation in the Python SDK is a killer feature. Because I think that's the point of this, isn't it, really? That Python, you can do what you like, but your API, you can't. So if you send garbage to the API, that's a bad thing. If you can stop that garbage at the SDK level, that is better, isn't it?
Yes, of course.
Yeah, and that's essentially what we're doing here. So if I take an example, so I'm going to use an example of our llama store. I'm going to drop a link to this in the chat, actually. I've got this llama store that I created. It's a project that we use to show off kind of a lot of liblab's capabilities. It's based off the Swagger pet store, but 100% more llamas. And I've got a spec in here. So if I bring up my spec, for example, and I look at, say, my user registration object, this has got like an email and a password. Now, when I pass this to anything, I can pass either a dictionary or a strongly typed object. If I try and bring this up in my SDK, so I go to my output, source, llama store, models, I've got this strongly typed object, this user registration object that has an email and a password field. But I can pass the dictionary as well, because Python doesn't care. So if I go to my service that uses this, my user service, I have this register user, this thing here. And although we've got this type hint, you say Python's not strongly typed, this is a type hint that hints that this can be user registration. I can pass in anything. And so because we have this cast models, you're saying I could pass in a dictionary here, and it would work as long as the dictionary matched the fields that the user registration object has. Is that right?
Yes, that is right. If your dictionary contains the fields that the user registration contains, then it should pass. If not, it would fail.
Okay, so let me bring up my example code here, because I did create a little example here. So I want to do this user registration. I can say, let's make this a little bit bigger. I can create my user registration object with an email and password, and that would work. But also I can create a dictionary, pass that through, and it would work. So you know what? My llama store's running. Let's pray to the demo gods. Make sure we've done this. Where are we? Here we go. Now I've prayed to the demo gods. I've eaten the sacrificed chicken, and that was a rotisserie chicken from Costco. Obviously, I'm not going to sacrifice one myself. But in theory, if I run this, if I run Python casting.py, oh, this is always the way, isn't it? But we still see, I think it's always the way, because I broke something else later on in my code. But the point being, we try the use. I know what I did. Let me just restart everything, because my user already exists. So in theory, if I just run this again, I'm having one of those days today, aren't I? There we go. So what we're seeing is the user is created. So both are working. When I create my user here using the strongly typed object, it works. If I create my user using a dictionary, it works. So I kind of got that power. And as you say, if I put garbage in here, let's actually try the garbage option. Let's just restart my llama store so I don't have my user already created. If I go to my dictionary and I put some garbage in here, what's going to happen is it will fail. So it's doing this validation, isn't it? And this is failing at the SDK side. So yes. I've got some code in here to log when we actually make the request. So I'm making a request with a user that works. You'll see this before request is called. But when this one's failing, it's not doing before request. So it's not even hitting the API, is it?
No, that's one of the good stuff. Like most of the APIs are paid, and you don't want to keep like. Imagine that you're using your SDK to automate something, and it's a backend service that will keep running and running and running, and like you might be trying and failing a lot of stuff, and you can like easily spend a lot of money. If it's the Twitter API, for instance, you could spend a lot of money.
Yeah, I mean, I get say about a lot of money. It's like all these AI ones, all these large language models people are using. They charge you per call. So if you're calling ChatGPT out of, and you're passing a big stack of tokens that's costing you like 10 cents for every call, and you've got an automated job that keeps retrying it, and you end up you can spend thousands without, just because you've got something wrong and you're constantly retrying it. So this is pretty cool. And you can cast as well. I remember seeing something in the blog post about this, and I wrote a little demo for it. We automatically cast. So if I'm passing a dictionary For example, this age field should be an integer in my llama. If I can bring up my spec for my llama, I have this, where are we? I have this age field, which is an integer. Now, if I set this to a string, this cast models decorator, that will actually handle this, won't it?
Yes, I believe so.
Nice, nice. So again, it's that as part of the casting, if you put the right value in the wrong field, in the wrong type, but it can be casted, we kind of get that. So it makes it more usable, doesn't it? So if I'm generating SDK and I give this to my users, as long as they're setting what is essentially the right stuff, they can do it in different ways and it will work. But if they send the wrong thing, it will error at the SDK side.
Yes.
Very
And
cool.
that requires the user, of course, to have a good spec as well. Of course, we can help people with that as well. But yes, you could do, for instance, a validation for your email. You want to, like, you only accept emails for some kind of organization. Then you could create a pattern match, that kind of stuff, and that would also be validated. But so we also have we accept a lot of the validations that the OpenAPI specs allow you to put in.
Yeah, because that's kind of the next thing you mentioned in the blog post, isn't it? It's the idea of validating the input. So as well as the casting, we validate against these patterns, don't we?
Yes,
So,
I'm getting ahead. Sorry.
no, it's true. It's pretty cool. So if I look at my spec, for example, I have got under user registration, I've got an email and I have this pattern here, which is something at something dot something. And this, like you're saying, you could put, if you wanted to only allow people from a specific organization, you could be something at liblab.com or something like that. Yeah. And that goes in the spec. And again, this is, I think your point, you're saying you need a good spec. It's garbage in, garbage out. If your spec is garbage, then your SDK will be garbage. So you need to have a good spec for this. But if you put that in the email, you know what, let's try that. If I just go back to let me just restart to delete all my users. So if I try that in here, I'm saying, yeah, you know what, let's just comment out all this stuff in here just to get rid of noise. I'm going to create a user, and here's my email. We'll just do no one. Oh, can't type today. So if I run this, bang, this failed. And again, this failed at in the SDK because invalid value for email must match the pattern. So because this doesn't match that pattern, we've got that validation kind of built into the cast models.
Yes, that's one of the things that I like about our SDKs. This ability of also validating the input and not throwing requests unless they match the API requirements.
Because I'm not seeing that output that I have when it makes a request. So we haven't hit the API yet. I've kind of got this stopping you early on, which is very, very cool. Joshua asked a question. He says, being an SDET, which is a software development engineer in test, for those who haven't come across the term before. Joshua, correct me if I'm wrong with that definition, but basically it's an engineer who is responsible for building automated testing, managing the testing process. So not QA in the manual button clicking kind of sense, but actual engineer who builds testing tools. Says, I'm curious how you do testing for this. Are there unit tests and mocks for the generated SDKs?
Okay, so for the generated SDKs, we used to have unit tests in the version 1 of our languages, but we found that that's not actually very useful because we are generating code again based on the spec, and well, if the spec is wrong or if our generation code is wrong, the tests will be incorrectly generated, so that they don't mean much in terms of validation, right? So, and yeah, someone was questioning internally also, like, so we need tests tests for our auto-generated tests, and that would create an infinite loop and something like that. So yeah, what we are doing, like we have of course our internal battery of tests for each specific cases, and then we do tests internally, but we found that unit tests in the generated SDKs are not very useful because of that.
Yeah, so I guess because if we've got an API spec, if we build a unit test, it uses basically a mock based off your API spec, and all we prove is that the SDK can call something that looks like your API spec. But really, the customer's going to have to, our customer's going to have to build unit tests anyway to test against their real API, because they're going to probably have some kind of sandboxed environment that they want to run their tests against. So we can't generate that. All we can do is mock the API spec. And as you say, we've got our own internal testing so that we know that the SDKs we create work with the API specs. But yeah, the customer's going to have to write their own tests against the actual data that their sandbox environment is going to return. So yeah, you end up with, we build automated unit tests that don't get called. So
yes, but one cool use case for an SDK would be to build a good end-to-end test for your API. Because if you have something that like fails if it's not validated, and you can trust that the input you're sending is matching the requirements of the API that you defined on the API spec, then it makes it much easier for you to know if it's a real problem on your API, or if it's just like a type or something like that, or something that's not a real problem. So yeah, one cool thing to use that people could use liblab for, that sometimes people don't realize, is like you could write a good end-to-end tests for your API using the auto-generated SDKs based on your needs and that kind of stuff.
Yeah, because the SDKs are very strict to your API spec. Whereas if you write an end-to-end test manually by just calling the REST endpoint, it's not strict to the spec. It's your interpretation of the API. So if you want to verify that your API spec is right, having this auto-generated SDK that only knows what is in your spec is great for end-to-end testing. I've actually never thought about that case before. So yeah, that's a really, really good case. Okay, I feel like a blog post is coming on from using SDK generation to test your spec. I feel that's a blog post coming on. And yeah, Joshua is confirming, yes, that software development engineer and test is also known as a QA engineer. Cool. Yeah, thank you for confirming that. Cool. So yes, so this is the validations. So this is kind of a great thing we've got in that SDK, these validations, that we make sure that it aligns to the different types that are in there, which, yeah, really powerful, because if we're hitting an API, you don't want to be hitting an API with absolute garbage. You want to make sure you catch that earlier. So Joshua makes another point about this, saying, I've done a lot of API adapter SDKs for Playwright tests. Playwright is an automated web testing framework. Very cool bunch of folks work on Playwright. Actually, I know a couple of them. Great bunch of folks, and they get really gnarly. So yes, if you're testing APIs, then anything that can auto-generate something based off your spec is a really great thing to help with that. So yes, okay, I am now thinking I need to write a blog post on this, because this is a very, very cool use case. I like this. See, even I learn things on these streams. You know, so you kind of think, well, there's these folks from liblab doing a live stream. They know all the stuff already, and you know, it's a great opportunity for me to learn. So this is cool. So we've talked about casting. How the fact you can pass anything in, and we make sure that it's right. We validate the types that go in. Next thing you mentioned in this post is about building the request, and I like this quite. I never thought this was from Zen of Python. I'd heard of Zen of Python before, never really thought about it before. But yeah, there should be one and only one obvious way to do that, which makes so much sense, really, because if you make it hard, have multiple ways of doing it, you don't know which is the right one. So Talk to me about how we build the request.
Okay, so our path to build a request comes from it starts on like the cast models that they are making sure that you're passing the correct thing, and we also have a set of validator rules that are added as the first thing, and then we start request. Yes. And after that, we start the request builder, which is what this session is about. So we have our own serializer. Sorry, I'm not native in English, but we use it to build the request, and we accept all kinds of ways that you can serialize parameters and requests that are accepted by OpenAPI. So you start building your request, adding parameter per parameter, query per query, and then if you go to an auto-generated SDK and you actually look at the code, this is one thing very important. When you look for generated code, sometimes you open it and you can't understand a thing about what's happening. But when you open this request builder, you can see the steps that are being made to create your request. We are adding a path called llama ID, and we are adding a query limit, all these steps that we are doing. And we build your request and we serialize. After we serialize, we have a request object, and then we just set the method and the other stuff necessary for other kinds of calls, like the content types and the kind of stuff. But we build it step by step, so the people using the SDK will know what's happening just by looking at it.
So this is in the generated SDK, isn't it? So
yes.
As an end user, I've got this SDK from this company. I'm using the SDK. I want to actually dig into the SDK code. I will see this. So it's kind of obvious to me what's in the code. So if I needed to go into the SDK code base to debug something, am I doing something wrong? This is very obvious how the API call is being built up. So if I'm testing it, if I'm actually at the customer who's generated an SDK and I'm testing it before I ship it to my end users, I can look for this and I can do my testing and understand it better. Oh, this is how it's calling my API. And then, as when I give this to my end users, they've kind of got this, oh, this is a well-built SDK kind of thing. Because I guess that's kind of part of what we want to do at liblab is build SDKs that our customers are proud to put their name on and ship. So this is a really nice looking SDK. So if I'm a liblab customer, I would be really happy to ship this to my users. So let's actually have a look at that in my Llama store. So I'd find that this is in the services, isn't it? So let me just expand that.
Yes, services.
Yeah, because I guess actually, for those who've not seen a liblab generated SDK, let's maybe take a second. This is what's generated, this Llama store. And I've got these different folders in here and this SDK.py. So Dallas, as our resident expert on this, what are all these? Can you just explain the structure of this SDK?
Sure. Like we have a very simple structure. The SDK.py holds the main SDK client that you will use as your starting point for everything. So you build your client, and from there you can pick, you can access wherever you have within the SDK. And then we have our folder for hooks. Hooks are a way of extending functionalities in the SDK, so you can customize what happens before and after a request, what happens if an error happens. So we accept all that, and hooks could be the topic for one entire live stream. So I think I will not dive too deep on it today. After that, we have models, which holds the models that will be used in your requests or responses. So this contains the information that you need to know to build like the inputs of your request. And also some validation if the model contains it. And the net, which is the network layer, it contains everything that we need to send and receive requests. So it contains the header classes, the environments that you can use to set up, like you can have a sandbox or a production environment, different kinds of it. The user can easily switch from one to another. We have something that we built that's called the request chain, which is the steps that we'll take for your request. So it's kind of it's basically a linked list that says what should happen with your request. So the steps that needs to be taken and the hooks that will be called in which order. So yeah, the handlers folders contain this list of things that will happen. So in yours we have the hooks, we have the HTTP handler and the retry that it's opt-in or not. You can or not have a retry on your SDK. So yeah, request chain, and we have the transport, which contains the request error, the request and response classes, and the serializer. So yeah, and some utilities. So yeah, the net is about that, sending and receiving the data, and the services, which contains the main, the core stuff for our SDKs. Usually a path on your spec becomes a service, and it contains the methods that you can use to send a request. So yeah.
Okay, so if I take, for example, my spec here, I have under paths, let me just clap some of these down. I have like a number of different user functions here. So I've got under user email, I've got a get, under user, I've got a post. They exist on my user service. That's my user service here. And then I've got register user, which is my post. I've got get user by email, which is my get. All this comes from the operation IDs in my spec with our nice cast models to do all our validation of what comes in. And then what these do is this, then it's got the validator. So this is what we saw earlier, validating like emails to be the right pattern. And then this is the serialized request in here in my service, where we start with the URL, we add the path to it, we serialize it, and we call a get on there. So it's kind of this lovely structure. So if an end users look at this SDK, oh, what does this get user by email method do? Validates the email, builds an API key, sends the request, deserializes the result. It's kind of very obvious. It's kind of really nice and clean, so that I can have confidence in this code that I'm using. I've been given by some API company. I can have confidence in this because this is really nice structured code.
Yes, it might also help you realize like some mistake on the request, because the JSON or the YAML format, they are not very clear for that. You have the properties, the spread. Sometimes they are in a schema on the bottom, and there you have everything that you are using, and you can realize, oh, you could realize, oh, but this doesn't go here. This is not a query parameter, for instance. It should be a path or something like that. So you can realize like if you made a mistake in your spec as well by looking at the code.
So kind of debugging, if I've got something in my spec that's a header, but I should actually set it as a path parameter, for example, I could stick a breakpoint on here and say, oh, well, I'm adding this header, but actually I should be adding this as a path parameter. So kind of really help me debug it. It's really clear when I'm stepping through it.
Yes.
And same with this whole kind of this net folder. This is like how we add headers. So if I want to check what's going on with auth in here, I can stick breakpoints in here and see what's happening with the authorization headers. If I want to see what's happening with this with the request chain, so what's going on with my hooks that I've written or my retry logic, I can stick breakpoints in here and verify what's happening. So if I'm not sure about my spec, it's easy to navigate around the internals of this SDK for debugging purposes.
Yes.
Yeah. Which is very, very cool, because I mean that's kind of important. We as a company, we have a tool that generates SDKs for people, but those generated SDKs are part of the product for our customers. So they've got to be proud of that product to ship it. They've got to make sure it's an SDK that they're happy with. You know, we keep saying we generate the kind of SDK that your engineers would build themselves. And this is like that, isn't it? This is a really nicely structured SDK. So that it doesn't look like generated code. It looks like a very smart engineer built this.
Yes, that was the intention, of course.
I mean, obviously it helps, Dallas, that you are a very smart engineer. So, you know, it's really cool stuff, this. I love this. Cool. Okay, so we talked about how we build this. And then, and you've even got some great examples about the non-default styles of things. So I have to ask, I never really understood these. What are these kind of explode methods? Because I know you can specify in a spec that you explode parameters. What does it all mean?
Okay, so there are different ways of serializing a path or a query. And in the end, they always come to the way you separate your query parameters, or the way you like for the explode. I think I'm not sure, but because the explode and the style, they might change the way, like the style can change the way that the explode works, I think. But mainly the explode makes you to have like parameter equal something and parameter equal something instead of a list of just queries.
Right.
Again, I don't remember very well because there are a lot of these rules. So when I was developing this solution, I had the OpenAPI specs page here and the code editor here. So I was constantly checking what was the rule. We have a lot of styles, and the explode, in the mix between explodes and styles, they can create different things. But yes, they are different ways of serializing your URL. So some APIs accept one format, some APIs accept other formats, and then we want to support all the possible formats.
And I guess the upside to an SDK now is you've done this hard work. You've been there with the API spec and the code, and you've made it work so that if I'm using an API, rather than have to look at their API and go, okay, well, how am I supposed to do this? Instead, I just use the SDK, and all this is handled for me. So all I have to do is just pass the properties through to the call, and internally, the right magic will happen. I don't have to work out how to explode things manually.
Yes.
Nice, because that is one of the big upsides to an SDK is we abstract away a lot of those complexities. You know, like you're saying about the whole retry thing, we abstract away how to retry. We abstract away how to do authentication. We abstract away all these weird and wacky ways that you can do parameters. It's like, whatever, just pass your data through and we'll do everything for you, which is very cool.
Something that we will talk later probably, but you can even just copy the snippets and put the information that you want inside of these snippets and send it.
Just copy and paste from the docs, because let's be honest, we're engineers, we copy and paste from Stack Overflow, you know.
Yes. That is the biggest source of errors in our world, but we keep doing it.
Stack Overflow and GitHub Copilot, it's all someone else's code. Cool. Okay, so we talked about we validate the input, we structure it, validate it, pass it through to this lovely chain of things, and then the output comes out. And again, we have to think about validation on the output, don't we? Because garbage in, garbage out, but also there could just be the API is just returning garbage. There are rules in the spec around what fields are there. So we also do this output validation, don't we?
Yes, we cannot build a safe SDK if we don't have that. If you think like you are expecting your response to have, for instance, a page, then you are using the SDK and the API doesn't return a page, but you go there and type .page, and then you break your own stuff because of the API. But so that's confusing. So that's why we later like inform you that an error happened in the response and like give you the error, then giving you a response that in theory is incorrect. Then you because if we give you incorrect information and then you try to access it, will get an exception, and that will be harder to debug than if we just say like, oh, your response failed, here is why.
Okay, so as like an end user of this SDK, if my code breaks because, oh, this property is not on this thing, I'm going to assume it's my code. But then again, if I see an exception to say, hey, the API didn't return these expected fields, I know that's the API's responsibility, so I can go back to the API company and say, oi, you're sending me garbage. What's going on here? Yeah, it kind of helps me isolate the problem. I know it's not me. And that again is really powerful, because how many hours are wasted? You're like, no, the API must work. The API must work. I'm doing something wrong, and you're not. So yeah, you end up, oh, I'm going to manually deserialize the response. I'm going to fire up Postman. I'm going to make a call. I'm going to look into it. When we're going to say straight away, nope, you're expecting this field. It's not there. That's their problem.
Yes, and then you can go and directly open a GitHub issue if you have access to that or something like that. Yeah.
Yeah, so much faster for that debugging flow. And I guess, again, we're talking about using SDKs for testing. This is great for testing because I can write that end-to-end test that uses the SDK to call the API. And then if I get an error on the way back, I know that error is in my API, as in what is coming back from the API doesn't match the spec. I can catch that and then using the SDK for the end-to-end test. Very powerful. Nice. Nice. And then as we come back, we need to think about mapping. So readability counts. Yes, yes. I think this is so important because one thing that a lot of people forget is when we write code, we're not actually writing for computers. We're writing for people. Yes, the computer is what turns our code into something that works, but essentially we're writing for people. When I write code, a human needs to be able to read that code, and that human could be another person or it could be me in a week's time when I forgot what I do. So readability does count. Very important expression. But yeah, so talk to me about mapping.
Yeah, so all languages, they have their own pattern when it comes to if you should write your stuff in snake case, camel case, and that stuff. So your API usually reflects the pattern of the thing that you use to build it. So if you build it in TypeScript, then it will most likely be camel case. While if you have a property camel cased in Python, it will look very weird. Some linters can comply about that, and you'll have your code all yellowed, and yeah. So to avoid that, we do a mapping between the properties of your API and the patterns for the language. So we are snake casing in this example all the stuff that needs to be snake cased, so they all look Python code. And you could have a messy API as well, where you have some things snake cased and some things like not, some things camel cased. So we would just we would keep what is snake cased and just change what needs to be changed. So that's something as well. So yeah, so we need to map for you so you can input snake case, and before sending to the API, it's important that we use the reverse map to send the correct properties. So I could not send is enabled as a snake case in this example. We need to revert it. So I use the map again to send for the SDK, and then I get the response. Again, I need the map to map it to the snake case functionality. But again, it's all clear there if the user take a look. Like it's easy to realize what this code is meant for as well.
And Joshua does a great point here. Broken readable code can be fixed. Working unreadable code can't be easily changed. I think that's so true. It's if you can read the code, you can fix it, you can understand it, you can enhance it. If you can't read it, then all bets are off. And this kind of helps with that readability. You know, the fact that some of it is just making it look nice. As you say, snake case for Python, camel case for other languages, you know, so this is making it look nice. But by having this JSON map here, you can actually see what it's doing. In fact, if I go into the code, this will be in the models, won't it? So if I take a model and look at, say, an API token, here's one of these JSON maps. So in my spec, let me actually bring it up in the spec. Under API token, I have two properties, access token and token type. And these are camel cased because this is the correct casing for JSON. But obviously access token doesn't make sense as a property in Python. So in my API token, API token in Pascal case as the schema type gives me API token in Pascal case for the class because that's the right type. But my properties are access underscore token, token underscore type. That's the right casing for Python. And then we don't do the magic behind the scenes, do we? We actually explicitly have this JSON map defined right here in the model. So as an SDK user, I can see this. I can see that the access underscore token field maps to access token and token underscore type maps to token type. So that if what I'm getting back from my API doesn't match the casing in my spec, this is going to help me debug it, isn't it?
Yes, that can help you debugging. It is a bit of a magic because the decorators are doing it out of the box, but you can see the intention of it, which is the important thing. You can see that we are doing this map. You could also see if you try to just copy your dictionary to a Postman, it won't work. But you can go there and see, okay, this maps to this, and I could adjust. Of course, if you use liblab, you won't need because you have the documentation. But well, that's just something to an example.
Yeah, but it's a good example, isn't it? It's if I take the JSON that I'm generating here and I want to test it in Postman for whatever reason, as you say, it won't work because the casing's wrong. But literally, it's JSON map. So if I want to do this in JSON, this is the mapping that we're doing. So it's I can tell that this is the mapping I have to do to make valid JSON. It's kind of it's intrinsic in the name, so it's kind of a nice feature. As okay, my JSON's not working. Let me actually look at the model. Okay, yeah, this is what it is. So I like that. I really like the fact it's there. It's in my face. I can see it as an SDK user. I can see this. Cool. And I guess as well, this is not just for casing, is it? Because what about if I've got a reserved word?
Yeah, I forgot about that. A reserved word, a number, something that can't be like a property. Then we also apply the same casting. We change it to something that works in Python, and then we map it when sending. You could have a property that's called one, like the number one. But then if you try to put one in a Python code as the property name, it will fail. So we need to convert it to something that works in Python, and then of course when we send to the API, that will be mapped.
Yeah, I guess the naming of that is not going to be great. We can get _1 or something. It's impossible for us to come up with a good name for something like that. So whatever we come up with, it's going to be okay. But if what's generated in your SDK doesn't look great because using reserved words, well, the fix is to fix your spec, isn't it?
Yes, and we are using underscore because we did some research, and it's the most common thing in this case. So if you ever you probably saw that somewhere already when you need to have a number property or something, then you underscore it and that kind of stuff. So yeah, there is no one thing is to accept there is no good way of fixing names. So then you don't try to to do something too much fancy. It usually ends up looking worse than what you started with. So we just for that cases we just change.
Yeah, because the right fix is you fix it in your spec. There's kind of nothing we can do. So it's the old joke. It's the 4 hardest things in computer science is naming things, cache validation, and off by 1 errors.
Yeah, I just knew the first version that stopped in cache validation, and then didn't knew this one.
Naming things, cache validation, off by 1 errors. The 4 hardest things. Cool. Okay, and then I guess the last little bit want to touch on is descriptions and snippets. And again, great quote: "In the face of ambiguity, refuse the temptation to guess." And this is, we're basically adding the inline documentation to make your life easier, which I think is fantastic.
Yes, and of course, these documents can be used to generate doc files with strings, and they can also be converted with the correct tools for other kinds of doc strings if you prefer that.
Yeah, because there's a number of different ways of doing doc strings in Python. And so, yeah, this new, the SDK generation version 2, we're using restructured text. I always find it funny because REST is a way of talking to APIs, and it's also a type of documentation for Python. Restructured text is known as REST. So, yeah, in fact, we've got this REST format. It's great. So if you wanted to build Python docs that are in standard Python format, you can use Sphinx to generate this. There are tools to convert this. And then let's just see it here. Here we go. Here's my nice restructured text. It's anyone who knows Python can look at these and naturally scan these because you're used to seeing this all the time. The access token parameter, here's the description. The access token type is str. So it's a really nice way of documenting it. So I'm glad we've got this in here. If I go and look over here, I just hover over VS Code. Unfortunately, VS Code doesn't format this nicely, but PyCharm does. Other Python tools do. And I know there's an open issue with Pylance to actually format these better. But this is the standard, so should be support in VS Code for this at some point soon. But yeah, PyCharm and other tools will format these absolutely perfectly. And as you say, you can convert it to any other format. So if you want it in NumPy format or Google format, there are tools to do this conversion. It's we're starting with that base level. So this was a feature I was very excited to get, I must admit. So cool. That is an overview of our Python v2 SDK generation. So a lot of cool stuff there. I think we kind of need to finish by just talking a bit about how we turn this on. So if you're already using liblab, then all you need to do to turn this on is just add liblab version 2 to your liblab config file. So I'll show you my config file over here. Just touch on this. In my config file, under Python, language options Python, I just drop in liblab version 2, and that will generate it. Literally, that's all I have to do, isn't it?
Yes, just that, and you will get the new SDKs. Yeah.
But I think we also need to add, if you've already generated a Python v1, generation SDK with Python v1, v2 is not necessarily compatible, is it? So there will be breaking changes between what you generate.
Yes, there will be breaking changes, and you can, of course, you can do the adjustments that you need. But yeah, it's important to know that this is a new version, and therefore things are done a bit different from the first one.
Yeah. So if you've already got a Python SDK you want to generate, make sure you bump your major version for your SDK version to let your end users know that it's a major version bump and it's got to change. So, if it's a migration you want to do, you want to plan that migration, think about it, check it out, look at the breaking changes, work out how your end user is going to deal with that. Talk to us as well. If you need help with your migration, we're here to help with that. But if you're starting off brand new with your first Python SDK, liblab version 2 is the default now. So if you generate a new config file with liblab in it, it defaults to version 2. So any new SDK you build will be automatically use a version 2. But if you are doing that migration, then if you've got any questions, reach out. We'll be here to help. But yeah, otherwise, thank you everyone for joining us. Dallas, thank you for your time. Got a clap from Joshua. I always struggle to read these emojis, whether it's a wave or a clap. But yeah, Dallas, thank you for your time. It's been a lot of fun hanging out with you on the stream. I've learned things, which is always good.
Yeah, thank you for hosting this. It was interesting. I also learned a lot, and we could talk about a mandolin, which is pendolin here. Yeah.
So the most important thing you've got from today is you've learned about mandolins and mandolins. Cool. This is what this is all about. It's all about having a bit of fun, isn't it? But yeah, everyone who tuned in, thank you for watching. If you're watching the recording, then thank you for catching the recording. Well, this is going to be on YouTube. So if you're not watching this right now on YouTube, this video is going to be on YouTube. We'll put links in the description with all the links to everything. Otherwise, you want to come and join us, you want to sign up for liblab. I'm just going to put a link to liblab in the chat as well. Joshua says I'm going to that he'll put some cool videos in the Discord. Yes, put some stuff on our Discord. Join us on our Discord. I will just actually, let's just drop a link to the Discord. Join us on our Discord if you're not there already. We're here to answer your questions. Just chat, geek out on SDK generation, whatever. But otherwise, Dallas, thank you for your time. Everyone who has joined us today, thank you for your time. This was a lot of fun. Enjoy the rest of your day and have fun building SDKs with liblab.